Hi, this is Gary Rubenstein. I'm a math teacher. I've been teaching secondary math for almost 30 years. But I also have two children, one who's now going into fourth grade and one that's going into seventh grade. So I've gotten recently to really see how math is taught in the elementary schools and the topics that they do. And I also got a brand new Apple Pencil and iPad that lets me draw nicely. So I thought I would make a series of videos, which I'm calling right now, What Does My Kid Really Need to Know About Math? Because there are a lot of topics they teach, and some of them are less important than others, and some are really important, but you wouldn't realize that unless you knew like what was coming next. So it's hard for you to help your child like focus on like what part is like really important. So I'm going to tell you. So some of these are my opinions. These aren't based on educational research as much as watching, thinking about math. Even though I teach high school, I've taught people throughout my career who have been at different like levels of math, and I've seen a lot of the common errors that children have and things like that also. So I just want to get going with this. So one concept that you may have seen in like textbooks nowadays is the idea. I'm going to start with addition. Addition is a very important thing, and it starts with counting, but then it builds up to addition, and being able to add numbers that together add up to less than 10 would be sort of the first skill that I think is important for like kids who are in, let's say, first grade. So adding two numbers, so the sum is less than 10. And also adding two numbers, so the sum is exactly 10. These are two different skills. For the second skill, there's really only five ways that if we don't count zero. So here are your basic five ways of adding up to 10. And there are different ways you can do this with kids holding up their fingers. They're very comfortable with with the number 10, and sort of seeing these sort of pairs. There's only five pairs: 1, 9, 2, 8, 3, 7, 4, 6, 5, 5. These are really important. But a second skill is adding, or that's my second skill. The first skill I was thinking is just adding two numbers so the sum is less than 10. So you ask something, like what is 3 plus 4? And by working with questions like that, you can take out, you can take out 9 pennies and basically, just ask a kid any question of two numbers that add up to less than 10, and they can experiment by putting, for 3 plus 4, just putting the 3 pennies here and the 4 pennies here and counting them to see that it's 7. They start to get, comfortable with that. The idea that 3 plus 4 and 4 plus 3 are the same number. That will seem obvious to them, but in higher math, that idea of what you can switch around and what you can't becomes sort of more sophisticated. I think knowing these 5 pairs for the second skill is an important skill also. But the third skill is adding two numbers so the sum is greater than 10. And a nice visual that I've seen is something called, I think it's called a 10 frame. When my daughter was in first or second grade, she did a lot of questions like this, and you could look up resources. I'm doing this whole video series just kind of off the top of my head, so I'm not prepared with all kinds of like images and things like that. But the idea behind a 10 frame is to model 8 plus 5. We could put the 8 dots into this. This 10 frame is a 2 rows by 5 columns grid. And to even make 8 and know that 8 is 5 plus 3, that's kind of gives us a little bit of number sense also, like the idea that any number is like, any number bigger than 5 can be thought of as 5 plus, a little bit more. In this case, 5 plus 3 is 8. But to do 8 plus 5, you take the 8 red dots, and then in the 10 frame, you try to put the 5 yellow dots. But what happens is that it fills up, because 8 plus 5 is bigger than 10, it fills up that 10 frame. So you can see that the answer is 13 because it's all 10 plus these extra 3. Now you might look at that and say, well, how is that any better than just doing start at 8 and just count 9, 10, 11, 12, 13? It's a little better, and it's actually more sophisticated than it seems. The idea is that you're changing 5. First of all, you know that 8 plus 2 is a pair that adds up to 10. So we're thinking of 5 as, we're splitting 5 up into 2 because 2 is the thing that becomes 8. 2 is the thing that you add to 8 to get 10. So this is kind of what we're doing. In other words, we had 8 plus 5, but we're thinking of it as 8 plus 2 plus 3. And I split up 5 to 2 plus 3 and not 1 plus 4, because I want to get to that 10. And this is a skill that I see as a really important one. Here's another one, so 7 plus 4. There's the 7 and the 4. The first 3 fill up the 10, and there's an extra guy there. So the answer is 11. But it's kind of thought of as 7 plus 4 is the same thing as 7 plus 3 plus 1, and that 7 and 3 is 10. Anyway, I see this as an important skill, because eventually when they get into like second and third grade and they start doing questions with the standard algorithm, why don't I use the example from before? Let's go like this. What was it before? 8 plus 5? So when they're doing standard addition algorithm, I'll talk more about this after, but you do often have to do something like, we start by doing 7 plus 4. And if in our mind we're able to add 7 plus 4, if the answer is bigger than 10, in our mind maybe we think, oh, 7 plus 4. Well, 7 plus 3 would be 10, but it's not 7 plus 3, it's 7 plus 4, so it's 11. And here we have 1 plus 7 plus 5, which is 8 plus 5. Again, 8 plus 2 would be 10, but it's not 8 plus 2, it's 8 plus 5. Well, 5 is bigger than 2. It's 2 plus 3, so this ends up being 8 plus 5 is 13. I'm just fast forwarding. I'm not saying that first graders doing all this with carrying yet, but I just wanted to mention that this skill of adding two numbers that are bigger, two what are called digits, numbers between 0 through 9 are the 10 digits, knowing that that sometimes they add up to more than 10, and knowing that two numbers when they do add up to 10 can help us add up two numbers that add up to greater than 10. Here are some other skills, and I'm not saying that you do these skills necessarily in this order, but what I'm saying is that if my child is in finishing first grade and they can do these three things and these three things, I'm actually pretty happy. Like, even if that's all they learned that entire year, I would be kind of pleased. I mean, there's some other like problem solving I'd want to talk about also, but as far as like the math skills, I think if my first grader knew all 6 of these, I would feel they were really on the right track. So for the first of these skills, I mean, if you have 9 pennies and they get a feel, and when you say something like, 9 minus 2 equals 7, or 6 minus 4 equals 2, a nice thing that I remember my children learning about is these sort of, they call them like number families or something like that. But the idea that every addition problem, like 2 plus 7 equals 9, that's the relationship between the three numbers 2, 7, and 9. And those three numbers, yes, you could say 2 plus 7 equals 9. You could say 7 plus 2 equals 9. But there's also, I think they call them related facts, 2 subtraction facts that are kind of embedded in here. And I find these 4 concepts here, it's not as obvious. It's not really that obvious. If you take 2, if you kind of had 7 plus 2 to become 9, and then you took away the 2, you'd be back to 7. But if you did 2 plus 7 to get 9, and then took away the 7, you'd be back to 2. Again, I'm not saying you do this with first graders, but the idea that any addition problem has sort of 3 other problems that are related to it, that's a really important concept for this number 1. So if students are good at this first concept of just adding 2 numbers where the sum is less than 10 and they get comfortable with that, then subtracting something, this says less than 9, I should say less than 10. So it would include like 9 minus something. Now, this second skill, subtracting a number from 10, well, if they're good at if they really know their 5 pairs, which, as I mentioned, you can have them hold up fingers and kind of just get a feel. I found that my own kids they were really comfortable with these 5 pairs. And if they know those well, then you can say, what's 10 minus 3? And if they know that there's this pair, the 3 plus 7 pair, to get 10, well, then 10 minus 3 is 7. And there's, of course, only 9 questions you could ask about this skill. Those are like the 10 facts. Let's cross this one out. And I call that my second skill for subtraction. But really sophisticated is this third one. If you take a number that's between 10 and 20, some kind of, I call it a teen. I'm going to count 11 and 12 as teen. I remember, when you say 13, it means 310. And in other languages, some of their numbers are said that way. So like 11 could be like 1 teen, and 12 could be 2 teen, and 13 is like 3 teen. Anyway, what I'm getting at is if you take a number like 11 or 12 or 13, 14, 15, 16, 17, or 18, actually you don't need 19 for this, and you were to subtract something from 11, but subtract something so that the answer gets less than, so that the answer is less than 10. So for instance, like 11 minus 7, for example. The idea here is that 11 minus 7 is like 11 minus 1 minus 6. I chose to split 7 into 1 and 6 because 11 minus 1 is the thing that gets me 10, and 10 minus 6 is one that I would know because of all these, the pairs, 10, 6 plus 4 is 10. And you can do 11 minus anything that way. Like 11 minus 5, for example, is like 11 minus 1 minus 4, which is 10 minus 4, which is 6. Well, you can do this for any number, like for instance, if I take 13 and I want to subtract 8 from it, I can say, well, 13 minus 3 will get me down to 10, which is, that's an easy one. But then I need to take away 5 more. Why 5? Because 8 is 3 and 5 together. So this is 10 minus 5, which is 5. Now, I'm not saying that the children should literally write 13 minus 8 and write it as 13 minus 3 minus 5. I'm kind of showing that to like adults that are like thinking about this stuff. I probably should, maybe I should put in a skill here that I didn't mention. I'll call it 3A, which is doing something just like 14 minus 4 equals 10, 16 minus 6 equals 10, something like that, 18 minus 8 equals 10. You may say, well, that's totally obvious, but it's not to a child thinking about it. But that is a skill they need to know also. I'll call this 3A. I'll call this other one 3B now. So if I want to practice this teen minus number, like 16, I have to take away something bigger than 6. Like I have to do either 16 minus 7 or 16 minus 8 or 16 minus 9. So let's just say 16 minus 9. I think of it as 16 minus 6 minus 3. Minus 6 because that's the thing that would make it 10. Minus 3 because 9 is 6 plus 3. And just to make up some more, like 15 minus 7. It's like first take away the 5, but then I have to take away 2 more. So these are just, I'm talking about like if my first, even second grader can do these skills, 7 skills now that I've made this a 3A and 3B, I'd be pretty happy as far as just like calculations go to prepare them for some of the algorithms. Maybe I'll, like first, second grade. I don't know exactly what the cutoff is about when, what age I'm going to be like happy, but I think first, halfway through first grade or into second grade, if they can do these 7 things, that is pretty good for as far as calculations go. Now I want to say a little bit about what I'll call standard algorithms. By this I mean, how do we do like adding and subtracting larger numbers? Well, there's the way that most adults learned with carry the one or borrowing. And then there seems to be this other way that students are learning nowadays, so-called Common Core math. And some of those Common Core math things that people look at and think are some like new crazy things are actually things that have been around for a very long time. And there's a chance that you, even if you're an adult now, learn stuff that way. And I'll tell you what I mean by that. You take something like 37 plus 45. And now the standard algorithm, the thing that they say, oh, they don't learn that way anymore, they do it this new crazy way. Well, this is the old way, right? 7 plus 5 is 12, but you put a 2 here and you carry the 1, and then you add 1 plus 3 is 4 plus 4 is 8. You get the right answer. And a lot of people say, well, what was wrong with that way? It was great. I got really good at it. Well, there is nothing wrong with that way. So what is like the Common Core thing? Well, one Common Core idea, and again, it's really not a Common Core idea, is to think of it like 37 is really like 30 plus 7, and 45 is 40 plus 5. And what if I were to add together the 30 and the 40 first, and then I added the 7 and the 5, and then I took those two answers and put them together? Well, as you can see, it's the same answer. But you wouldn't say it's crazy to do it that way. So this is like, is it Common Core, or is it like a nice way to visualize what happens? Because if you do this way, where you, in fact, you could even, maybe I go from here and I rearrange the numbers, so I write 30 plus 40 plus 7 plus 5 plus like that, and then I put those together, and I put these together, and then I write 82. You wouldn't think that was crazy. Even for this one, imagine I wrote 7 plus 5, and I just wrote 12 right here. You say, well, that's not the answer, but that is 7 plus 5. And then when I do the 3 plus 4, it's not really 3 plus 4, it's really 30 plus 40. So I put the 70 here. And then I add those together to get the 82. People look at that nowadays and say, well, that's a Common Core thing. That's not the way I learned it. But isn't it really? I mean, look at the difference between what I just did and what happens when I put the 2 here and carry the 1. That's just saying that 7 plus 5 is 12, so it's a 10 and 2 ones. And then I put the 10s together. 1 plus 3 plus 4 is 8. But if I had my student, if my student was doing something like this, I wouldn't be unhappy about that. That's a good method, and it helps them understand the so-called standard algorithm. Some people are defending. I'm not saying that I love everything about the Common Core. Some people defend the Common Core by saying, in the old days, we carried the 1, and we had no idea why we were doing it. And that's just not true. I could find math textbooks going back, in America, to the 1700s, where they explain why they carry the 1. So it's not like before Common Core, we just told people carry the 1 and you have no idea why you're doing that. Other things about like carrying the 1, you could use money. You could say like 27 plus 36. You could actually have like 2 dimes and 7 pennies. And you have 3 dimes. And 6 pennies. Well, when you put them together, what do you get? Well, you have 5 dimes now. And you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 pennies. Well, no reason to carry around 13 pennies when I can trade 10 of those pennies for 1 dime, so now I end up with actually 6 dimes and 3 pennies. Well, that's what's happening. 7 plus 6 is 13. But instead of having 13 pennies, I trade 10 of them for a dime. That's why I put a 1 up there. And I just all I have is these 3 pennies left. And now I add together the 3 dimes and the 2 dimes plus the 1 extra dime I got when I traded the 13 pennies for a dime and 3 pennies. So money is a good way to understand the standard algorithm. There are some common core things that I don't like that much. Like I see this a lot. 27 plus 36, and they say like, see some number lines. They're like 27, and then you see some strange, some things that maybe are a little unusual, like friendly numbers. They like go like that to get to the number 30. They're trying to add 36 to 27. So far they've added 3. Now they're at what they call a friendly number. So now they can add like 30 more to easily get to the number 60. But now they've only added a total of 33, but they were trying to add 36. So they need to add 3 more. I'm not like a huge fan of this number line thing because sometimes I see students make all these distances all the same size. They don't get a feel for like 30 is bigger than 3. So I don't find that this one really I don't find that it really helps kids learn that well. I'd much rather see 20 plus 30 plus 7 plus 6 is 50. Remember, 7 plus 6, that's 7 plus 3 plus 3, so 50 plus 13. I don't know. I mean, the one thing about this method is that sometimes kids will do this. They'll say 27, then they'll add, maybe they'll add 30 first to get to 57. But they need to add 6 more, but they don't want to add 6 right away because 57 plus 6 might be too big, so too big of a number to do in their head, so they add 3 first to get 60, and then another 3 to get 63. Anyway, if you've seen this one and you feel like, I don't know, it seems kind of confusing, I'm in agreement with you there. But if you've seen something like this, and you say, that's not how I learned it when I was a kid, well, it's not so bad, really. It really gives a concept of why we carry the 1 and what it means to carry the 1. I'll finish out this video with subtraction algorithms. So this is where you have like 53 minus 28. Now the standard algorithm is to say, well, 3 minus 8 I can't do, so I change this to a 4, put a little 1 here. 13 minus 8 is 5. 4 minus 2 is 2, you get 25. So people say, well, that's how I learned it, and I turned out all right. So what are some common core things? And I don't know, what's really going on here? Well, I like to think about money again. If I want to think 53 minus 28, I imagine I have 5 dimes and 3 pennies. And somebody asks me for 28 cents. They want 2 dimes and 8 pennies. And you could actually hand a kid, 5 dimes and 3 pennies. and say, hey, I want you to give me 2 dimes and 8 pennies. Well, they can give the 2 dimes, no problem. But they can't give the 8 pennies because they only have 3. So you say, well, here's a bank, and you can, anytime you want, trade a dime for 10 pennies. So then you take one of these dimes and you trade it for 10 pennies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I can subtract 8 pennies because I have so many. I have over 10. I have 13. And when I take away 8 from there, 1, 2, 3, 4, 5, 6, 7, 8, I'm left with just 2 dimes and 5 pennies, which is 25. So when we compare that, when I say 53 minus 28, I could do 53 minus 20 first. Get 33. That's what happened when I went over here, when I took away those 2 dimes. But I still have to take away the 8. Now 33 minus 8 is kind of like 33 minus 3 minus 5. 33 minus 3 gets me to 30. Again, I'm not saying that the kids do it this way. I'm just showing you. I like this thing with the pennies. And then you say, okay, well, 53 minus 20. What if I go back to my pennies? What if I go back to this situation with the dimes? And I said, okay, you have 53, 1, 2, 3, 4, 5. Those are the dimes. And I have the 3 pennies. And I want to take away 28. But I don't want to do the 20 first. I want to take away the 8 pennies first. I want to do the 8 first instead. So already I'd run into trouble. I'd say, I don't have 8 pennies to give you. So at that point, you take one of the 10s, trade it in for the 8 pennies. Trade in the 10 for 10 pennies. And then I can take away 8 of them. And I have just 5 pennies left. But that's, I've only taken away the 8. I also have to take away 2 of the dimes. Well, that's kind of what's happening when we do the standard subtraction algorithm. We say 3 pennies minus 8 pennies I can't do. So I'm going to trade one of these 5 dimes in. So now I only have 4 dimes. But my 3 turns into 13 because now I have 13 pennies because I traded one of the dimes. 4 with a 13, I remember telling my child they could count and say like 4013, which is the same thing as 53. That's kind of what this is. You could take any number. You could take 27 and think of it as, actually, let me say, 37 I could think of as 2017, like 20 plus 17. So 53 you could think of as 4013. That's kind of what happens here. But now I have 4 dimes, 13 pennies. 13 minus 8 is 5. 4 dimes minus 2 dimes is 2 dimes. So that's like what the standard algorithm means. But I will admit that some of the like Common Core like subtraction, it's not that it's so bad. I'm going to stick with 53 minus 28. You could say like 53 minus 3 is 50. But it's hard because that means I haven't taken away all 28. I still have to take away 25 more. So now I can take away 20. And then take away 5 more. That's very like, I see this on the Common Core a lot. 53, people might go like that. They might take away 20 first and say 33. And then they still have to take away 8 more. Some kids maybe can go straight to 8 more. But some kids might go like 3 more first. So that gets me just down to 30, and then the 5 more. It's actually pretty hard to do that sort of common core way, but it is interesting, like thought-provoking, like how many ways can you subtract 28? There's like different ways to do it, and which way is easier for you. But I am a big fan of the regular algorithm, but it's good to like have some, motivation for it, like with the money, to explain sort of why it works. Well, that's all I wanted to say for this first video. This is basically, honestly, if my third grader, I just have a child who finished third grade, and he was actually struggling with standard algorithms. They had taught a lot of the Common Core ways, but they didn't like connect it. The whole point of the Common Core is to eventually get to understanding, not just to understand the standard ways, and so you can do it that way. He was pretty good at doing like this kind of thing, but it took a real long time. So during remote learning, I showed him how to do this, but not just in a blind way. I really went through like the motivation. We got out the money, the pennies and dimes and things like that. I'll talk about 3-digit stuff another time, but if after third grade my child can do all the stuff in this 40-minute video, they're in pretty good shape. They're in really good shape for, at least for their calculations. Like I said, there's stuff with, measuring and how big should this room be, and there's what I'm calling like problem solving and real world things about if someone has an apple and they give some away. I mean, we want to also be able to do those sorts of things. But these skills are really important, and that's my first video about elementary school math, where I'd want my child to be by the time they finish second or third grade. Anyway, if people watch these videos, I'll make more of them. See ya.